The dreaded measurement and proportionality assignment. Many of you guys, this was work we did in class. We're gonna go over it. I'm gonna go through it pretty quickly, as I tend to do. Again, you could always go back, rewatch what I do, rewatch what I say. We had discussed this in class. Maybe you can compare what we're talking about here to notes of your own. If you miss class entirely, there should be enough here for you guys to get your work done. But measurement and proportionality, this is about making scale models. So, first of all, scale models are things like this boat, where when you're designing something, when you're building something in engineering, you don't want to make a $10 million yacht without knowing what it would actually look like, how big it would actually be, like things like this. So we always want to make a scale model first. A scale model is a kind of prototype. We've talked about prototypes before. They're initial drafts when we're designing things. So this is a scale model of a yacht. Now, when we make our scale models, it's important that our scale models are identical to the actual thing we're trying to build. Identical in every way besides size. So that means it should be just as long, it should be just as tall. Its proportions should be the same. So when we talk about proportions, we're talking about proportionality. Proportionality is the idea that we have this smaller scale model, and there's some number that we can multiply it by, that we can multiply its size by. Its bounding box is something I'll say. You don't need to know what bounding box means precisely. It becomes more and more obvious as we go through the year when we talk about Tinkercad. Don't worry too much that I said that. But proportionality means that there's some number that we can expand the shape by, that we can increase its size by to get to the shape of our actual thing that we're trying to build. So for this example, we have this scale model, and it's a square, and one side is 1, and the other side is 1, so it's a 1 by 1 square. This square is a scale model of this square because we can just double the length and the width. So we can double its size. We're going to call that doubling its size. And that gives us something that's 2 times as big. You could also argue that this is 4 times as big because it has 4 times as much area. But we're just going to look at the perimeter when we talk about this. And not only just the perimeter, we're going to talk about the total height of something. So let's say let me make this more clear. Let's say I have this stick figure, and we wanted to make a scale model of him. The numbers we would be looking at is his height and his width. So he fits into this rectangle. Those are the numbers we're looking at. So let's say he's, 6 feet tall, and let's say from arm to arm, he's, 4 feet wide. So he's 6 by 4. So if we had this as our scale model, maybe our actual person, maybe this is 6 millimeters by 4 millimeters, and our actual person is 6 feet by 4 feet. This would be a scale model of that because we could expand it. We could blow it up by whatever the millimeter to feet conversion is. We could size it up by that amount to get to our actual model. So that's what we're talking about when we're talking about proportionality. It means that there's some number that we can increase both of these dimensions to, all of these dimensions, by the same number to get to this new shape. So in this case, it's 2. In the square case, we're multiplying this 1 by 2, we're multiplying this 1 by 2. Since we can multiply them both by the same thing to get to these numbers, it's proportional. Just so this is more clear, let's go to these next slides where things are not proportional. So long as Screencastify lets me get rid of this pen tool. So long as Screencastify lets me get rid of this pen tool. Okay. So I guess I'm not going to blow up my slides right now because I'm stuck on this pen tool for a second. But these are examples of things that are not proportional. So here we have this rectangle, which is 1 by 1, and this one is 3 by 2. So there's no one number that we can multiply both of these ones by to get 2 different numbers, a 3 and a 2. If we multiply them by 2, we get a 2 by 2 rectangle, which would be too small. It wouldn't scale up to this 3 by 2 rectangle. If we multiplied them 3 by 3, it would be too big. it would be bigger than this 3 by 2 rectangle. And any number in between is going to give us some other shape as well. There's no way to scale this square, this rectangle, up to the size of this rectangle. There's no number that lets us do that. So these two shapes are not proportional. This square is not a scale model of this rectangle. This square, again, with this circle, there's no amount we can size this square up by to make it a circle. If we're changing nothing but its size, then it'll never be a circle. It's not going to change shape. And that's the goal, is to make it so that we're not changing anything shape. So these would not be proportional because they're completely different shapes. So let's talk about this in a practical example. Let's talk about this model of a yacht. So we have this scale model of a yacht, and this yacht is 23.8 inches tall. So that's this number is 20. I'm not going to be able to write it. Give me my eraser tool. So I don't know where my Screencastify tools went. I'm going to hit this undo button. Are you sure restart? No, let's not restart. Alrighty, we're stuck with some scribble scrabbles. My pen is broken. I don't see where my drawing tools are. So that's okay. Hopefully you guys fast forwarded through me looking for those drawing tools. But anyway, so we have a scale model of our ship. The scale model is 23.8 inches tall. It spans 118 inches long. So that's from back to front. Okay, so it's 23.8 inches tall and it's 118 inches long. We don't get the width, that's fine, we don't need it. So the actual cruise ship that this is a scale model of is 238 feet tall and 1,188 feet long. So how many times bigger is the real ship than the model? So you guys might want to pause the video for a second and just take a guess, just estimate. How many times bigger might a real ship be than this model? Okay, so you guys did that. Now let's find how much bigger it actually is. So this is 23.8 inches tall. Let's just look at the height, because once we know how much we have to scale the height up by, we know how much we have to scale everything up by. Because we're going to scale the height, the length, the width, whatever we need, we're going to scale it all up by the same number. So let's get this height number here, the height of the model, to match this height number here, the height of the actual cruise ship that we're building. So right now we have 238 and 238, but there's something different. This one is 23.8 and this one is 238. We also have a difference in the units. This one is in inches, this one is in feet. So let's get the number the same first. If the number is the same, that's a step in the right direction. So if we multiply this by 10, so times 10, that gives us 238 inches. So when we multiply this by 10, we now have, instead of 23.8 inches, we have 238 inches. But the actual model is 238 feet. So what would we have to multiply this 238 inches by? How many times bigger would the actual model be than this model? It would be 12 times bigger because we have to get inches to feet. So you need 12 times as many of this to get to feet because there's 12 inches in 1 foot. So if we have 238 inches 12 times, we have 238 feet. So we have to do times 12. And now the units will be the same. So now instead of inches, we have 238 feet. And I should just put little lines next to these, but it's fine. So since we have to multiply it 10 times bigger to get the right number and 12 times bigger to get the right units, we're multiplying it in total. We're multiplying it in total 120 times bigger. And another way to see that is if you look up at the address bar, I'm going to type it out. Let's say we start with 23.8 inches, and we're multiplying it by 10 to get the numbers the same, and we're multiplying whatever that is, we're multiplying that by 12 to get the units the same. But we could do multiplication in any order. So before we did this times 10, but if you look at it like this, where you're doing the 10 by 12 first, you see that what we're actually doing is we're making this model 120 times bigger, because 10 times 12 is 120. So this model is a 120th scale model of the actual boat. If it was 120 times longer, 120 times taller, and 120 times wider, this would be an actual yacht. But it's not, it's just a scale model. Let's move on to the next one, and perfect, my Scribble Scrabbles disappeared. I'm very happy. All right, so let's talk about the problems you guys have to do. So you have to figure out if this pool is a scale model by looking at the actual units and seeing which of these units would not be able to scale to these actual units. So I'll do A, and then you guys do B, C, and D and figure out which one's wrong, which one doesn't work. So for A, we have 7 feet, 5 feet, and 2 feet. So that's our model. Our scale model of this 7 meter, 5 meter, 2 meter pool would be a 7 by 5 by 2. I'm gonna use this convention. Instead of saying 7 meters long, 5 meters wide, and 2 meters deep, I'm gonna say 7 by 5 by 2. It's just a faster way to say it. It's a common way to say how wide, long, and deep, or tall, or high something is you say 7 by 5 by 2. So our original one was 7 by 5 by 2 meters. This one is 7 by 5 by 2 feet. So to scale feet up to meters, we just need to multiply it by 3.3. And then we would have, if we multiplied all of these by 3.3, it would be 7 meters, 5 meters, and 2 meters. So that's exactly what we started with. So this scales. So A would work. You should check the other ones and see if you can multiply them all by the same amount to get back to this one somehow. It might be more obvious than that. You might not need to do all the math and really think about it. It should be a little intuitive which ones would not be good scale models. But try to figure out which one is not a good scale model. This next problem is exactly the same. You're looking at the original numbers. You're figuring out which of these would not be a good scale model. Here's where things get interesting. Perfect. And I don't have that pen tool on my other pages. So here's where things get interesting. Is we want to build scale models of things of our own. We don't want to just look at other people's scale models or think about scale models. We want to create scale models. That's one of the really good uses of 3D software, 3D design software. So let's make a scale model of this apartment building. So this apartment building is 30 by 30 by 200 feet. We can make a scale model in Tinkercad that's the exact same dimensions, just scaled down. So we could take a box. Let me create a new design. So we could take a box and make it 30 by 30 by 200 millimeters. And then there would be some number. We don't know exactly what it is. We don't have to know. There'd be some number that we can multiply millimeters to get to feet. And our model would be that number scale model of this actual apartment building. So this would be an effective scale model of this apartment building. So let's make it right now. So again, the apartment building from the question was 30 by 30 by 200 feet. So let's make our model 30 by 30 by 200 millimeters. So we're just taking the exact dimensions it gives us in the question and making that model in Tinkercad. So this would be our building. And you guys can screenshot that and put that in here and put the dimensions of your building that you make. So in my case, it's 30 by 30 by 200, and my units is millimeters. Our units in Tinkercad is always millimeters. So that's for the building. I'll do one more because this one isn't the best worded question because I did it kind of as a reference to something one of my students likes. So this is a 50 millimeter cannon. So this 50 millimeter has to do with the bullets that it's shooting, not the actual size of the cannon. So I want to make sure to go over this one too because that can be a point of confusion. So the 50 millimeter has nothing to do with what we're building. What we need to build is a barrel, meaning a cylinder, a cylindrical gun barrel, that is 3 meters long with a diameter of 0.5 meter. So I'm not going to spend time explaining why this is true for those of you who don't know, but we talked about it in class for a while. But the diameter is just going to be, when you have a circle, it's going to be these two outside numbers. So if we wanted a diameter of 0.5 meter, we would do 0.5 and 0.5. And it wanted a height of 3 meters. Let's do 3. But this looks way too small to be an effective scale model. This doesn't look like something practical. If I printed this out and gave this to my military commander as a scale model of the gun barrel I wanted to make, I get laughed at. This is way too small. So what we could do is in Tinkercad, you can always hold shift. And while you're holding shift, if you resize something, it will keep it as a scale model. It will scale it up. It won't warp it or stretch it or make any dimension a different proportion. It'll give you a proportionate shape. It'll scale it up as long as we're holding shift. So now I know that 27 with a base of 4.5. So 4.5 by 4.5 by 27 is a correct solution. So 4.5 by 4.5 by 27. And again, I started just by putting in the numbers it gives me in the question. So 3 with a 0.5 diameter. And then I scaled that up while holding shift. These next two questions are very similar. You're building a pool, which is going to be a hole, which could be slightly different, but you're just making the hole the size it gives you in the question. And this one's just a box again. It's making a box the size of the dimensions it gives you in the question. You're going to want to screenshot your work and tell me the units you ended up on. If you use units different than what it gives you in the question, but you scale them up or down a little bit, I'll give you some extra points for doing that extra step. That's it for this assignment. Hopefully it's not too bad. Hopefully you guys can add to it, make up some work. I should have had this video up sooner. I apologize. You're all great students. You're all going to get this done. Have a great, great week, everyone. Bye, and I'll see you all in class when I do.